Let's take a look at this this test, this example. And so as it comes up, yeah, it's not going up very fast. Okay, use the slope-intercept form in linear equation to write the equation line with a given slope and y-intercept. Okay, so our slope is equal to 4/7, and our y-intercept is equal to 0, 0. Now our slope-intercept form is y is equal to mx plus b. When they give us a slope, they're giving us m, so I'm going to have y is equal to 4/7 x plus, and when they give us y-intercept, of course, they're giving us b, which is 0. So my answer is y is equal to 4/7 x. Type your answer in slope-intercept form. Y is equal to 4/7 x. Go to the next problem. Find the equation line. Write the equation in standard form. Slope 0. Pass it through a point 2, 1. I got y is equal to mx plus b. So step 1 is to find m. Well, it's given. M is equal to 0. Step 2 is to plug in m, which we just found, and the given point for x and y. So I'll plug 1 in for y, into y equals mx plus b. So put 1 for there, m is 0, x is 2, plus b. And then we want to solve for b. Well, 0 times 2 is 0, so we got b is equal to 1. Now step 3 is to write down our answer. Y is equal to mx plus b. M is 0, b is 1, so we got y is equal to 1. Question is what this book considers standard form. And I don't know if it'll let me go back to check that or not. Let's see. Standard form. Normally, standard form is ax plus b is equal to c. But some books put the c on the same side as the ax, and if I said that right, we write it out. Most times your standard form is ax plus by is equal to c, but there's some books that put the c over on the same side and you have 0 over here. Chapter opener. And so slow today. Of course, I'm rendering a video here, so after this gets done, it'll probably speed up. So I don't think I have anything else consuming CPU. Yeah, let me close that and try it again. It's just about there. Okay. Yeah, we'll go on. Now that would be in standard form if the numbers would be on the right side. Use integers or fractions for any numbers in the equation. Okay. Let's take a look at this one. Find equation line, write the equation using function notation. Through f or 5, -3. And we got 5y is equal to x minus 10. And it's perpendicular to this. Okay, so perpendicular to this. So let's find the step 1, find the slope. Our first substep within that is to write the given line in slope-intercept form. So we're going to divide everything by 5. So we got y, remember there's an invisible 1 here. So we got y is equal to 1/5 x minus 10/5. Or y is equal to 1/5 x minus 2. Now our second substep is to identify our slope. If you got in a slope-intercept form, your slope is whatever number's in front of your x, which is 1/5. Perpendicular lines have slopes that are negative reciprocals. So we're going to take our 1/5, you write it in fraction form, it's already in fraction form, you flip it, that's the reciprocal part. So bottom goes top, top goes bottom, and then you change the sign. So I got -5/1, so the m we're trying to find is going to be -5. Step 2. Plug in the given point, and I'll put function notation here in a minute. Plug in the given point for x and y. So this is x and this is y. Now realize that's a specific instance. There's actually an infinite number of points, but they're giving us a specific instance. And m is -5, and x is 5 plus b. Now we want to solve for b. So -5 times 5 is -25. Take -25 over, becomes a +25. And you got b is equal to 22. Now step 3 is to write our answer. And so we're going to plug in m from step 1c, which is -5. We'll plug in b from step 2, which is 22. And technically this is in function notation form, but I'll pick a notation and say f of x. When you talk about write the equation using function notation, normally you could use any function notation, but notice how here they're giving you f of x equals. So they're just wanting us to write the right side, which is -5x plus 22. And let's see if my ebook has come up here. There it is. Doesn't like that. There we go. And let's see what equation of line, graph of line using slope-intercept form. Okay, so see here's x plus 2y is equal to 6. That's normally what your standard form, general form, looks like, where you have a your numbers on the right side. Doesn't say that, but let's see. And okay, not seeing anything there. I'm guessing. See how the numbers on the right side right here. So that looks like the pattern. Usually you have your x first, your y second. Even more than that, some books say you cannot have fractions in here. So you have to multiply by the LCM of all your denominators. But the instructions on that one were pretty clear that it said to go ahead and leave it in fraction form. Okay. Find equation in line graph, write the equation in standard form. Let me clear this off. I have to apologize for kind of clearing my throat every now and then. I'm getting sick. Negative, this is negative 3, 1. And what is this point? This point is 1, 2, 3, 3, 5. Although there's different ways of getting the slope, I'm just going to use the formula. So step 1, find m. M is going to equal to y2 minus y1 over x2 minus x1. When we're given points, this is x1, y1, this is x2, this is y2. You label one of your points, x1, y1, and one of them x2, y2. Doesn't matter which ones. y2 is 5, minus y1, which is 1, over x2, which is 3, minus x1, which is negative 3. 5 minus 1 is 4. A negative negative gives us positive, so we got 3 plus 3. So that gives us 4, 6, or m is equal to 2/3. Now the 4, 6, changed in y, I should be able to see it. I should be able to go up 4, 1, 2, 3, 4, and right 6. 1, 2, 3, 4, 5, 6. Okay, so that excuse me, that checks. Step 2. Plug in the given point for x and y and the slope you found in step 1. Doesn't matter which point we plug in, both of us give the same answer. I'll plug in this one, doesn't have any negatives. So put 5 in for y. M we just said was 2/3. And x is 3 plus b. 3's cancel, and I got 2 plus b. Take 2 over, becomes a negative 2. 5 minus 2 is 3. So then, we plug in m, which we said was 2/3. And we plug in b, which we said was 3. Now it specifically says to write it in standard form. Simplify your answer. Doesn't say anything about fractions. Let's go over here and see if I can see anything about fractions. Okay, using slope-intercept form, right? Slope of a line, graphing linear functions, introduction of functions. My first inclination, since it didn't say anything about fractions, is to get rid of the fractions. We'll know when I submit it whether we get the correct answer or not. The equation of the graph line is negative 3x plus 4y is equal to 11. I'm going to say no fractions since it doesn't say anything about fractions. These are times when if you do get it wrong on the test, just let me know. I'm not going to count you wrong because you didn't put in a fraction or you did put in a fraction. Okay, now standard form. We need our x's and y's on the same side. Typically, the numbers in front of the x you want to be positive. So I'm going to take the y and move it over here, and I'll take the 3 and move it over here. So we got negative 3 is equal to 2/3 x minus y. Now again, I want to get rid of the fractions, so I'll multiply everything by the LCM of all our denominators. So I'll multiply the negative 3 by 3. I'll multiply the 2/3 x by 3, and I'll multiply the negative y by 3. So that gives us negative 9 is equal to 2x minus 3y. Now, I don't know why, but typically I like the 2x minus 3y be on the left side and the number over here. Okay, so 2x minus 3y equals negative 9. Now, one thing I always do when I check these, I mentally check them. I got negative 3, 1. I just plug negative 3 and 1 in here and see if that works. In here, this was a negative 3 and 5. I plug negative 3 and 5 in here. Wasn't negative 3, 3, 5. So I plug 3 here and 5 here. That's 6 minus 15, negative 9. Okay. Find domain and range, showing also determine where the relations of function. Domain is our x values. My eyes can see that good. It's like negative 5, negative 1, 0, and 4. How do I know that? Well, if I come up here this point, the x value is negative 5. If I come up this point, the x value is negative 1. This is 0, and this is 4. So these are our x values of our points. Now the range is our y values of our point. And it looks like all of these come over here to negative 1, negative 2, negative 3, negative 4. This one comes over to the y-axis at negative 3. Is the given function is the given relation a function? And that says for each x value there's only one y value. And so this particular point here, there's only one y value for this x value. And same with this. Now how you could tell them if there wasn't is if I had, let me draw a picture. If you had a different graph where I had, for a particular x value, I had a point up here and I had a point down here. So maybe this point up here might be 2, 3, and this point down here might be 2, negative 4. See how for this x value, there's two different y values? So basically, see it lined up vertically, that's where you have an issue with points. So it's a given relation of function, yes. Grab a drink here. Okay, salesperson's salary depends on the amount of sales per week. Get the full amount of sales and corresponding weekly salaries, plot the data points, and find a linear regression equation that describes the salary in terms of sales. Okay. Now our linear regression I apologize for how slow this is. First off, I guess plotting the points. Well, here's up now. Let's look at the plotting points. 1,720. Let's see what these tick marks are. That's not very useful. But I would assume that it's either this one or this one. The progression of these, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. That makes sense for these tick marks if each one is 1,000. Maybe it says that. It doesn't say that. 1,000, 2,000, 3,000. Yeah. These would be the same, but this is straight across, which means all the y values would be the same. And this one means all the x values would be the same. X being my sales, Y is my salary. Now it looks like they're increasing. 720, 892, 1064, 1322. So I don't even, without even really looking at it, Has to be this one. It's the only graph where they're increasing, except for this one where x values are always the same. Now, linear regression. I'm going to plug this in the calculator. So I'm going to do stat, do enter on edit, and if I have numbers here, I'll press delete where they're highlighted to clear them out. And I'll put in 1,000. I'll put in 3,000. I'll put in 5,000. I'll put in 8,000. And then for my y values, I'll put in 720, 892, 1064, 1322. Okay, that looks right. And now I'm going to do my you may have to set your diagnostics on to begin with. So you may have to do second, then 0 to begin with, and then you push your X and -1 button here to go down to the D's fairly fast. And you want diagnostics on. They already might be on, but if you choose that, then press enter. Now we're going to do stat, right arrow to calc, and then we want to choose the fourth one, linear regression, and then press enter. So it looks like, and I'm going to plug in the A and B into this regression. So I got 0.086, 0.086x, what is B? 634, so plus 634. Okay, I'll go to the next one. Rock has dropped from the top of a rock has dropped from the top of a 500-foot cliff. Okay, 500 feet cliff. The rock has dropped. Okay. After 1 second, the rock is traveling 48 feet per second. Let y be the rate of descent, next be the number. Hint, use the order pairs. Okay, 148. I'm not very good with physics, so I was hoping to give me a hint. 148 and 144. Okay, so we want to write a linear equation. So step 1, we want to find m. And m is equal to y2 minus y1 over x2 minus x1. Now this is my first point, so this will be x1, y1. This is my second point, so this will be x2, y2. So we're going to have 144 minus 48 over 4 minus 1. 96. And 96 over 4 minus 1 is 3. So that gives us m is equal to 32. Step 2. Plug in the given point for x and y. Doesn't matter which one you pick. I'll pick this first point. Numbers look smaller. So I'll plug 48 in for the y. M we just said was 32, and x is 1, plus b. And then want to solve for b. So I take 32 over. I got 48 minus 32 is equal to b. B is equal to 16. Now step 3. Plug in m from step 1, which is 32. Plug in b from step 2, which is 16. It's at least x, okay, it's 32x plus 16. Now here, rate of the travel of the rock 5 seconds after it's dropped. What is y? Y is feet per second. Okay, so it looks like we just plugged 5 in for x. So we got y is equal to 32 times 5 plus 16. And that's going to give us 160 plus 6. And that's going to give us 176. So it'll be 176 feet per second. Maybe. I assume this is not a trick one. It could be that it's already hit the bottom of the ground, which means it'd be 0, but we'll assume it's not a trick one. Okay, find equation line, slope is that, and do that point. So let me clear this off. Okay, so slope is 5. And passes through a point -7, 2. And it says to find equation line. Well, step 1. We want to find our slope, find m. Well, that's given. M is equal to 5. Step 2. Plug in your given point for x and y. So this will be x, this will be y. That's a specific instance we can use. So I got 2 for the y, m was 5, and x is -7, plus b. Then we want to solve for b. 5 times -7 is -35, plus b. Take the -35 over, becomes a positive 35. So we got b is equal to 37. Step 3. Plug in m from step 1, which is 5. Plug in b from step 2, which is 37. And we get this, but they do want it in standard form. So I'm going to take the y over to the right side and 37 over the left. Again, typically the number that's in front of the x should be positive if this book follows normal conventions. Though you'll find everybody seems like they have a different convention in that regard. But we'll see the answers here shortly. Okay, as a quick check, I'm going to plug in that point for x and y. -7 here and 2 here. That gives me a -35 minus 2, which is -37. Grab a drink here. Now this says find a domain and range, and it keeps going forever this way, it keeps going forever this way, so the domain is all real numbers. Now the range, our lowest point and our highest points, it keeps going this way, it keeps going down forever. As it keeps going this way, it keeps going up forever. So eventually it's all real numbers. Does the graph represent a function? Yes. There's very few lines that don't represent functions. The only line that doesn't represent a function is a vertical line. I guess that's all they're asking for. Find a slope and y-intercept of the line. We'll clear this off. Then we got -10x minus 11 equals y. Now our slope-intercept form is when you have it in the form y equals mx plus b, which is this is in the correct form. So whatever numbers in front of our x's are m. So m is equal to -10. And our numbers are y-intercept. Our y-intercept is -11. If you write it in point form, that'd be 0, -11. Okay, slope of the line is -10. The y-intercept. Simplify your answer, type an ordered pair, use integers and fractions. Okay. So this would be 0, -11. Okay, find a slope of the line goes to those points. Clear this off. I got 6, -5. And 6, -7. Right away I see it's one of the oddball cases because the x values are the same. But let's plug it in. Plug it in to m is equal to y2 minus y1 over x2 minus x1. This is my first point, so I'll label that as x1, y1. This is my second point, so I'll be x2, y2. y2 is negative 7 minus y1, which is negative 5, over 6 minus 6. That gives us negative 7 plus 5 over 0. And anytime you get division by 0, it's undefined. So that's B. Slope of the line is undefined. Graph this linear equation. Let me clear this off. Got 2x plus 3y is equal to 15. Different ways you can graph this. I'm going to show it on the graphing calculator. If I take 2x over, it becomes a negative 2x. And then divide everything by 3. This puts it in the slope-intercept form. And actually, whether you're doing it by hand or whether you're using a calculator, that makes it easier. Now you got y is equal to negative 2/3 x plus 5. Now the problem with using a calculator is my math lab wants it to be exact. So if I come here and go to y equals clear negative 2 divided by 3 x plus 5, and then you push graph, close enough is not good enough. Well, one thing you can do is you can go to your table mode, but first we're going to go to table setup if you've never been in there. We'll do second window, and you want your independent to say ask. If it doesn't say ask, you down arrow to that line, right arrow, and you put your flashing cursor on ask, and you press enter one time. And now if we go to table, second graph, you'll see some values here. And I don't want to use decimals. Negative 6.9, that's already there, but let's pretend it wasn't. You can plug 0 in. Now tell me one of my points is 0.5. So, to graph this, I'll choose my line tool. Boy, that didn't zoom it very much. I still can't see it very well. But when I move my mouse down, see how it says up in the upper right-hand corner, it tells you what the point is. That right there is 0, negative 5. So click one time there. Now let me put something else in here. Like if I put 1 in, probably won't work. We get decimals. 2 doesn't work, but 3 will, I think. 3, 3. So I'll come up to 3, 3. Keep an eye on that. There's 3, 3 right there. And then save. The reason why I said 3 will work is because if you look at your denominator, denominator is 3. So if you choose multiples of 3, in this case, then you would get answers that work out nice on your calculator. Again, close is not close enough when you're talking about my math lab. Okay, find equation line through this and parallel to this. Okay. So it's passing through the point, 2, 7, and it's parallel to y is equal to 4x minus 3. Step 1. First sub-step is write the given line in slope-intercept form, which means solve for y. It's already solved for y. Our second sub-step is to identify the slope. Well, if it's in slope-intercept form, our slope is whatever number's in front of our x, so slope is 4. Now we said that it's parallel to this line. We said the slope of that line was 4, and parallel lines have the same slope, so the m we're trying to find will be 4. Step 2. Plug in the given point for x and y. They're giving us a point, so that's a specific instance. And we'll plug in the m we just found, which is 4. So y is 7, m is 4, x is 2, plus b. And then we want to solve for b. 4 times 2 is 8. Take the 8 over, becomes a negative 8. And we get b is equal to negative 1. Step 3, write our answer. Plug in m from step 1c, which is 4. Plug in b from step 2, which is negative 1. And write the equation using function notation. So instead of y, would put f of x is equal to 4x minus 1. 4x minus 1. Sketch a graph of the function. Okay, so on my calculator, if I go to y equals, clear, and I'll type it as I see it. So I'll do a beginning parentheses, x minus 2, closing parentheses, squared, the x squared button, minus 3, and then graph. And which one does it look like? I guess it'd be A. So it looks like that one more or less. Plot the ordered pair, state in which quadrant on which axis point lies. Plot the ordered pair. -1.5 and -3. Probably need to know that the decimal of it. Choose a tool on a palette and follow the instructions. I don't have a palette. Oh. -1/2. Okay, I think that's -1/2, -1, -1.5 there would be -3. 1, 2, -3. Boy, that's really hard to see. I wish I'd put the point up here. Let me click save then. Huh. Which quadrant it is? This is the first quadrant, second, third. So that's in quadrant 3. And I guess that's it. Find a domain and range of the relation. Use a vertical line test to determine that it's okay. A domain. X values. Our leftmost point is right here and right here. If I come to my x-axis, that looks like -4. My rightmost point is right here, which if I come to the x-axis is like +4. So it's going from -4 to +4. Now our range. This is going to keep going down forever, so it's going to -infinity. This is going to keep going up forever, so it's going to +infinity. Now we're assuming it's following that same pattern, and that this isn't indicating it's going forever this way. If it keeps going forever this way, it'd be -infinity to +infinity for our domain. But anyway, that's that. Is the graph function? No. It fails the vertical line test. If I draw a vertical line here, it'll intersect at 2 or more places. Vertical members up and down. Okay, there it is. Graph the linear equation. We got y plus 3 is equal to 0. Now, if I solve this for y, I take the 3 over, I get y is equal to -3. Y equals is always a horizontal line at that number. So, I'm going to click to enlarge here, choose a line tool, go down -3, and I draw a point anywhere, and I come over somewhere else and draw a point anywhere. And that's my horizontal line at -3. Use vertical and horizontal shifts to graph the function. Okay, so first off, the absolute value is your V-shaped graph. What they mean by this is a -2 means it's shifted down 2. I don't know. Click these. Click graph first. Okay, click graph first. Now go down 2 units. Now the +5, when your number's inside of the x, it shifts left to right, opposite what you think. The +5 makes me think right 5, so it's really going left 5. So 1, 2, 3, 4, 5. And save. So I went left 5, down 2. Okay. Graph the linear equation. This is already solved for y, or f of x. So again, if I plug this in my calculator, close enough is not good enough. So if you do 2 divided by 3x, oops, clear. 2 divided by 3x, and I push graph. May not be good enough if I can't tell the points. Now if I go to my table mode, I do second graph. I see I already got 2 works real well here. 0, 0, and 3, 2. So 0, 0. I'll choose a line tool. 0, 0. What was the other one? 3, 2. 3, 2. 3, 2. Okay. Now what would tell me to choose is some multiple of 3. So like for example, if I put 6 in, that would come up nice. 6, 4. You don't go too far. If I put 30 in, excuse me, well, it gives me a valid point. I can't see 30 and 20 on my axis here. Might be a way to zoom it, but... And 20. Find the slope and y-intercept of the line. Now we got negative 4 plus y equals 0. If I take the negative 4 over, I get y is equal to 4. This is going to be a horizontal line at 4. Find the slope. When you got a horizontal line, your slope is 0. Find the y-intercept. Let's graph this. So it's going to be a horizontal line at 4. Now again, obviously m is equal to 0, and it crosses at 4, so my y-intercept would be 0, 4. Okay. Moment of truth will be coming up here pretty soon. Now we're going to graph these. Go back to y equals, clear. Now 2x minus 4, I'm going to put parentheses around it. So do parentheses 2x minus 4, closing parentheses, then beginning parentheses, and I'll put my condition. X is less than or equal to negative 2. So x, and then my second math to find the inequality. Less than or equal to 6, negative 2. Close parentheses, down arrow, and I'll put my second piece condition on this one. So I'll do beginning parentheses, negative x plus 2, negative on the very bottom row. And then it has to look exactly like what you're seeing here. And x is greater than negative 2. So go to my test, greater than negative 2, close parentheses, and then graph. Now what this doesn't tell you is it doesn't tell you whether it's solid or dotted. We'll get to that. I guess we'll get to that. The only one that even looks close is this one here. What would make it a solid is if there's a less than or equal to. See how there's x is less than or equal to negative 2? That's why this one would be solid. This one's x is greater than. That's why this is an open dot. Now our domain, it exists everywhere. So that's negative infinity, comma, positive infinity, range. Looks like it's got a highest point right here, and then this goes down forever, and this goes down forever. Question is what this point is. Let me zoom out a little bit. I see this highest point here is at y is equal to 2. But it's an open dot, which means it doesn't actually include it. So we're going to have it go from negative infinity, that's our lowest point, comma 2, and then parentheses on 2 because it doesn't include the 2. One more, and then we'll see what standard form really is like. Find equation of the line. Use function notation. Okay, so let me clear this off. Then we got 6/7, 12/14. Then we got negative 1/7 and 13/14. First thing we'll do is find our slope. M is equal to y2 minus y1 over x2 minus x1. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. So we're going to have 13/14 minus 12/14 over negative 1/7 minus 6/7. That gives us 1/14 over negative 1, negative 6 is negative 7 over 7. So that gives us 1/14 over negative 1. And positive divided by negative is negative, and the 1 doesn't do anything, so this just becomes negative 1/14. And that's M. Step 2. Plug in one of your points, doesn't matter which one. Second point, I guess. This is X and this is Y. So I got 13/14 equals M. What was M? Negative 1/14 times X, which is negative 1/7, plus B. So that gives us 13/14 equals negative times negative is positive. 14 times 7 is 98 plus B. Take the 1 over 98 over. Then we got B is equal to excuse me. X it out. Second mode. 13/14 minus 1 over 98. Enter, and then math, enter, enter. 45/49. 45/49. So my answer will be Y is equal to MX plus B. So we'll plug in the M we found, which is negative 1/14. And we'll plug in the B we found, which is 45/49. Now I'm gonna test this. I'm gonna plug in these X values and see if it gives me the Y value, because it's kind of a nasty fraction. Negative 1 divided by 14 times X. Let's plug in 6/7. 6 divided by 7. Then I'm adding 45/49 plus 45 divided by 49, enter, and then math, enter, enter. Gives me 6/7, which is the same as 12/14. Okay, so I feel better about that. So this is going to be negative 1/14 X plus 45/49. 45/49. Okay, I'm going to submit my test. We'll see how many I got wrong. Hopefully not all of them. Okay, I didn't like 21 and 12. Let's look at 12 first. Number 12. I thought I plugged that into the calculator. Okay. Let's try it again. See, I'm not sure what I did wrong. Not blaming my illness. 2x plus 3y equals 15. Let me solve for y again. Take 2x over. You got 3y is equal to negative 2x plus 15. Divide everything by 3. And you get y is equal to negative 2/3 x plus 15 over 3. I don't remember the negative before. Maybe that's where I messed it up. Plus 5. Plus 5 definitely should intersect up here. Okay. It's not a promising endorsement of the calculator. If I plotted points, I probably would have come up with the correct answer. Divided by 3x plus 5. Okay, so if I go to my second graph, the table, if I plug 0 is almost a perfect one. 0, 5. If I plug in a multiple of my denominator, like 3, 3, 3. Yeah, sure enough, 0, 5, 3, 3 would be right there. I have no clue what I did wrong there. I'm guessing I just messed up on a sign. And number 21. So it's going to come up. Oh, here it is. Range is negative infinity to 4. Oh, these are going by 2s. That's not 2, that's 4. 2, 4, 6, 8, 10, 12, 14, 16. It helps actually look at this tick mark up here instead of assuming they're by 1s. Okay. Well, you see the minor issues that I made there. So that's the review.